Hey everybody, today's a good day around here, and I'll tell you why, because we got our amp working. But let me show you what I've done since we spoke last. So first thing you'll notice is that this board looks different, right? Here's what was there last time when you saw it, this board. And you'll say, here he goes again, he ripped it out and did it again. But let me explain why I did that. If you look at the layout of this board, you'll notice that it completely matches the layout of the diagram that I have here. Right, so there's your capacitors, right? Same thing here. There's my capacitors. And the reason why I did that is I thought about this and said, I'm giving it to somebody, I'm not keeping it. And if someone ever has a problem with this down the road and they try to troubleshoot it, they're not going to have any idea where the components are because nothing's marked. So I said, okay, well, this layout here for the 5F1 is available online. And if someone were to get this amp and work on it, it would make a lot of sense because everything is laid out exactly the same way, right? So here's your 4 electrolytics, and here's your 2 resistors, for example. And if you look here, there's your 4 electrolytics, there's your 2 resistors. So I decided to just redo the board, so that's why that was done. So you'll notice that I've done things neatly again, and I've got everything tucked very, very well. I've capped off the 4 ohm speaker lead. I'm not going to put the selector switch in like I said I was. And the reason why is I only have one power tube, one output tube. And that would just complicate the wiring under here, and I really don't want to do that for this one. So I'm going to leave it as an 8 ohm unit, and we're going to just leave it there. So it does power up, and I'll show you what it does in a second. But I did a little research, and I found out that the 6v6 output tube, which if you look at the schematic, is right here. That's your 6v6 GT output tube. I found out that on these old Champ models that they would run very hot. And I did a little research and found out that the 6v6 GT tube has a power dissipation ratio of about 14 watts. Anything over that, you can destroy the tube pretty quickly. So I did a lot of research actually and figured out that the 470 ohm grid bias resistor, that's right here, which was standard on these, really isn't adequate for this amp. And the reason I know that is because doing the calculation I found out that my tube was actually dissipating about 19 watts, which means the tube wouldn't last very long. So what everyone suggests doing is changing the value of this resistor, which is exactly what I did. And this is the grid bias resistor right here. All right, so I've changed mine to 1K. Now the reason why that's important is that's what controls the life of the tube essentially. So by raising that up to 1K, I'm going to significantly increase the life of this tube right here. Okay, this output tube. And there's some research you can do on Google if you want to know more about that. But just to talk a little bit about theory, it's important that you know how to do the calculations. So what I did here to do the calculations is I measured the voltage across this grid bias resistor, and on mine I got minus 27.47. Okay, and the way that you check that is you check the voltage between the cathode to ground, right? And the cathode here, let's see if I can point to it. The cathode on this one, put a little light on here, is pin 8. Pin 8 is this yellow wire. So if I measure from pin 8 to ground, I should come up with a competing voltage on the positive side. So remember, we were minus 27.47 here. And when I did the measurement between pin 8 and ground, I came up with 27.55. So that basically means that they're canceling each other out, which is what you want. So that's an optimal number. I also checked the grid to ground, and that should be 0, right? And that's simply because if you look at the schematic again, which I have right here, if I look at the grid to ground, basically that's what this resistor is doing. It's going to ground. Okay? Right here, going out to ground. And then lastly, I did my plate current. And my plate current is between pin 3 and pin 8 on the 6v6 GT, and I came up with 415 volt DC. Right? So there's a calculation that you do to determine what your power dissipation is, and again, remember, this is with a 1K resistor. So let me show you the website that I did for that. So right here, you'll see total dissipation using plate current. Okay? Up here though, I'm using the cathode resistor voltage drop. So you'll see here, the number of tubes that share a cathode resistor is 1. That's just the one 6v6 tube. My voltage across the cathode resistor was 27.50 volts. I rounded it off. And my cathode resistor is 1K. And you'll see in doing the calculation that my cathode current is 27 DC milliamps, my plate current is 26 milliamps, and then my dissipation is 9.4 watts. So I went from up to 18, 19 watts on that tube down to 10, which is perfect. So that tube is going to last a long time now, okay? So I wanted to explain that. There's plenty of sites here that you can use, but I really learned all this from Uncle Doug. Uncle Doug has an amazing video series on using resistors and in circuits and things, and really showed me some good stuff there. Well, let's take a look and turn it on, and I can show you the one problem that I have left to solve. Okay, before I turn it on, I have a speaker plugged in. It goes down to this 8-ohm cabinet, okay? And I do have a guitar cable plugged in, which goes to this guitar. So we're going to power it up. Okay, we've got our Variac on 115 volts. And you'll see that our light is on. And we're going to let those tubes warm up. And by the way, what I was talking about with the 6v6 tube leads to red plating quite often if you don't address that. So by changing that one resistor, I think I've really changed the life of these tubes. You'll see that I've got the cover on the 12AX7 tube, the shield. Okay, let's let this thing bake up for a second. We've got our volume all the way down. Let's bring the volume up a little bit. So we've got sound, right? Now watch what happens when I turn the volume all the way up. Hear that? It's only when I go like between 9 and 10. So I have to figure out what that is. I do also have a hum on this thing, which some of it was just the guitar. It was basically feedback. But you see, I've got it working, and my voltages are good. And I'm going to spend today trying to understand how I get rid of that frequency. Not sure what that is yet. I'm going to just check some voltages and that kind of thing. It could be just a shielding issue. I'm not sure yet. But that's going to be my plan for today. So you'll see that we've got this thing working. And again, my board in there is really neat. And you'll see the standoffs there. There's plenty of airflow underneath there. I did order a 5-watt resistor to replace that 1K grid bias resistor, because that thing can dissipate quite a bit of heat. I've got a 2-watt in there. 5 is probably a little bit better. So I'm gonna wait for that to come in and then replace that resistor right there. But this thing is working, and after I go ahead and troubleshoot what's causing this little squeal, I'll figure it out and I'll come back and give you guys an update. So happy news here in the camp today. And then when we come back for the last video, I'll play a little bit for you. How's that? All right, guys. That's the update on this one. I'll talk to you guys later. This is Ron.